We have discussed about Hoffman. We have discussed about Gabriel thalamide synthesis and Hoffman bromamide reaction for the synthesis of amines. We have discussed about Gabriel thalamide synthesis and Hoffman bromamide reaction for the synthesis of amines. Now we are going to the third method, Hoffman aminolysis or X. This is or X alkyl halide or X alkyl halide. It is also known as haloalkane. Haloalkane, first chapter of organic chemistry, that is haloalkanes and haloarenes. Alkyl halide or haloalkane on treatment with excess of ammonia. We have discussed about Gabriel thalamide synthesis and Hoffman bromamide reaction for the preparation of amines. Now the next method is Hoffman aminolysis. In this method, or X, that is alkyl halide, common name, haloalkane IUPAC name, on heating with excess of ammonia. This is X is replaced by halide ion is replaced by ammonia molecule forming primary amine, and this is a kind of nucleophilic substitution reaction. Weaker nucleophile X minus weaker nucleophile substituted by means of stronger nucleophile alcoholic ammonia. It is stronger nucleophile. It is a kind of SN2 reaction, bimolecular nucleophilic substitution reaction. And this primary amine is a product will become the reactant again heated with excess of or X, HX gone, we will get secondary amine R2NH, 1HX gone, and now this is on treatment with again or X, HX gone, or3N. Again on treatment with ORX, we will get ORX will be added to this tertiary amine. We will get quaternary ammonium salt. So the disadvantage of this method is series of amines, primary, secondary and tertiary and quaternary ammonium salts are obtained. Instead of R, we can write CH3. Wherever R is there you substitute CH3. Let us suppose R here. X is equal to, let us suppose, Br. CH3Br. Bromomethane. Methyl bromide. Ammonia. Methanamine will get. This is N-methyl methanamine will get. N-dimethyl methanamine will get. This is tetramethyl ammonium hal bromide you will get. So wherever R is there, you substitute CH3. X is there, substitute Br. The disadvantage of this method, series of amines are obtained. Isolation, separation is quite difficult. If you use excess of ammonia, primary amine is a major product. If you use excess of alkyl halide or haloalkane, quaternary ammonium salt, which is used in detergents, in soaps and detergents, this is a major product. This is about Hoffman aminolysis. Now let us go to the next method, reduction of nitriles. It is also known as Mendius reduction. It is also known as Mendius reduction. Fourth method, reduction. Reduction is carried out either in the presence of hydrogen, add two hydrogens, two hydrogen molecules. In the presence of nickel, one hydrogen molecule to carbon, another to nitrogen, we will get primary amine. R is replaced by CH3. Add two hydrogen molecules. Two hydrogen molecules, just like basic equation, one hydrogen molecule to carbon, second to nitrogen, we will get ethanamine. Either you can use two hydrogen molecules in the presence of nickel, or four nascent hydrogen produced by sodium mercuric amalgam in the presence of ethanol. When you add hydrogen in the presence of nickel, it is known as addition of hydrogen. When you add this nascent hydrogen produced from this, it is known as reduction of nitriles, Mende's reduction. And in the place of R, you can use even C6H5 also can be used. Even C6H5 also can be used. The equation will be C6H5, C triple bond N with two hydrogens, one to carbon, one to nitrogen. That will become C6H5 CH2 NH2. This is a basic equation, or maybe aliphatic. You will get aliphatic primary amine, or maybe aromatic. You will get this is also primary amine. Aromatic, aliphatic, primary amine. This name is called benzylamine. Till now, we have studied 4 methods: Hoffman bromamide, Gabriel thalamide, Hoffman ammonolysis, and Mende's reduction. The last method of preparation of amines is the reduction of nitro compounds. That is nitrobenzene. This is nitrobenzene. Undergo reduction 2 times. Two hydrogens. One hydrogen. 2 hydrogens. You can write 4 hydrogens. You can write 4 hydrogens. 4 hydrogens you can write. 2 oxygen as 2H2O. 2H2O gone. 2 oxygen. 2H2O gone. And you can we have discussed about Gabriel thalamide and Hoffman bomb. We have discussed about Gabriel thalamide synthesis. And Hoffman bromamide degradation for the preparation of amines. Now the third method is reduction of nitro compounds. Nitrobenzene undergo reduction in the presence of 3 hydrogens supplied by palladium and ethanol. 2 hydrogens will be added to oxygen and gets eliminated as water. The remaining 1 hydrogen is added to nitrogen. That will become aniline, or it is also known as benzanamine. Aniline or benzanamine. It is an aromatic primary amine. Now the same concept is same. Nitrobenzene, instead of hydrogen, palladium and ethanol, we are using tin and HCl and iron and HCl. Iron reacts with iron scrap, board question. Iron scrap reacts with HCl, forming FeCl2 and 2 nascent hydrogen. write here as multiply and write as 4 nascent hydrogen. 2 will be added to that 2 oxygen gets eliminated as 2H2O, and the remaining 2 hydrogen as aniline or benzenamine. And this iron scrap is a best reducing agent because ferric chloride thus formed reacts with water and forming ferrous hydroxide ferrous chloride thus formed undergoes hydrolysis to form ferrous hydroxide and HCl formed. The HCl formed is again reacts with iron forming ferrous chloride. No need to add again and again HCl. HCl is again formed during the hydrolysis of ferrous chloride. This is about the reduction of nitro compounds. And this is we have studied about the reduction of aromatic nitro compound, aliphatic nitro compound, that is nitroethane, undergoes reduction either in the presence of 3 hydrogen and palladium or 4 nascent hydrogen supplied by tin and HCl or iron and HCl forming. This is 2 water will go, 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 and 1 as ethanamine. We will get, this is a third method of preparation of amines. Fourth method of preparation of amines is Hoffman ammonolysis. Alkyl halide haloalkane on treatment with excess of alcoholic ammonia, this halide ion is replaced. Halide ion is a weaker nucleophile replaced by stronger nucleophile ammonia, HX gone, leading to the formation of primary amine. Substitution of a weaker nucleophile by means of a stronger nucleophile by means of a nucleophile means electron-rich species is a kind of nucleophilic substitution reaction, bimolecular nucleophilic substitution reaction. Now this primary amine, again on treatment with alkyl halide, HX gone, we will get secondary amine. Again on treatment with alkyl halide, HX gone, we will get tertiary amine. On treatment with RX, just addition, it will become R4N plus X minus. Primary amine, secondary amine, tertiary amine. Primary means 1R, secondary means 2R, tertiary means 3R, quaternary means 4R. And the disadvantage of this method is all the amines are obtained in a serial way and their separation is quite difficult. And the next point, if we use excess of ammonia, we will get primary amine. If we use excess of alkyl halide, we will get quaternary ammonium salt. And the last method of preparation of amines is a reduction of nitriles. It is also known as Mende's reduction. This is called alkane nitrile. IUPAC name is alkane nitrile or alkyl cyanide. Undergoes reduction in the presence of 2 hydrogens, in the presence of nickel, or sodium mercury amalgam, in the presence of ethanol, or the versatile reducing agent lithium aluminum hydride and water. 2 hydrogens, 1 to carbon, 1 hydrogen, 1 H2 to carbon, 1 more molecule of H2 to nitrogen. Primary amine. Replace R by aliphatic. Ethane nitrile. This is ethane nitrile. This is also known as methyl cyanide. It is also known as acetonitrile. Undergoes reduction with 2 hydrogen, 1 hydrogen molecule to carbon, 1 to nitrogen, ethanamine. Likewise, this is general reaction. This is aliphatic, aromatic. This is called benzonitrile. This is C6H5CN, benzonitrile or phenyl cyanide. Benzonitrile. with two hydrogens, one to carbon, one to hydrogen, you will get benzylamine. Benzylamine. These are the methods of preparation of amines. Gabriel phthalimide, Hoffman bromamide, then reduction of nitro compounds, Hoffman ammonolysis, reduction of cyanides, or Mendes reduction. 5 methods. Take your textbook and practice now. It's